Hello and welcome to my second tutorial on Kerbal Space Program. The last time we got a rocket built and got it up into orbit. We're going to take up now where we left it off last time. The rocket's in orbit. Okay, here we are. And only have the lander part of it on left, but that should have enough fuel on it to take us all the way to the moon, because it's got 5 tanks here. So and we're only used up maybe a quarter of the external tanks. So we should be fine. Let's press M for map view. Okay. And what we did last time is we set ourselves up. If you look at the planet Kerbal from the North Pole, we're moving counterclockwise, and so is the moon. Let's move the moon to where it's we're looking at a clock, to where it's at the 3 o'clock position. This is the moon. So it's at the 3 o'clock position now. Let's switch our view by using the tab key to where our view is centered on the planet Kerbal. Okay, there's Kerbal, there's North Pole. Okay, we're moving counterclockwise, and so is the moon, and we're on a equatorial orbit. Okay. Okay, we got the moon at the 3 o'clock position. Now you may be asking yourself, well, the moon's far away and it's moving, so how do I get there? So, assuming that you've done everything in the tutorial up to this point, what you do is look at your 12 o'clock position up here of the orbit of the moon, and go to like 12:15. Okay, that's, if you look at the point on the on the Kerbal opposite that's about where we should do the burn to go to the moon. Now bear in mind that Kerbal is rotating also, so we'll have to do a second check once we get a little closer. So let's go ahead and speed up time. Okay, we're right about the right spot. Again, you're looking at the North Pole of Kerbal. You have your moon at the 3 o'clock position, if this is a clock dial, and sort of point to the 12:15 position, and then figure out the opposite point of that from the Earth, and that's about where we are. So let's go ahead and turn prograde. That's turn in the direction of our travel. Okay, excuse me, and we're going to do a burn. Okay, let's look at it from the top. You'll want to start with full thrust to begin with, and then as it gets further out, it seems like the range, the apogee gets further out faster. So once we get a bit further out, we'll slow it down a bit. Okay, you see as we get further out, the rate of change seems to increase. So let's go ahead and throttle it down. Okay, up here we should soon see that. Oh, shit. Sorry. Okay, well I overgunned a little bit, but we're okay. Let's go ahead and turn retrograde. This is a good lesson because sometimes you may have to correct that. So let's turn retrograde. Give it just a touch of thrust. Excuse me again. Okay, right now we're set to have the closest point to the moon be about 30,000, 40,000 meters. So that's perfect. Okay, see this funny little boomerang-shaped curve here? That's representing my encounter with the moon. This blue shape here is my orbit around the Earth. Now that looks really funky. It looks like I go up here, then I like to do a hard turn and go around the moon. Well, that's not really the way it is that just kind of the way it looks. But the important thing to see here, excuse me again, is that's when you start your moon encounter sequence right here at the perigee. This is where the moon will be when you get to there. This is the lowest part of your encounter with, or the closest encounter with the moon. That's when you want to do your burn to stay in lunar orbit. I'm about to start my lunar encounter. You'll see that this path will change to the blue color, and the other path will change to I guess back to the orange yellow color. Okay, now we started the lunar encounter, and it kind of looks like I'm about to run right into it. So let's fix that. Okay, let's suppose you're about to collide with the moon. You see here my orbital path passes right through the edge of the moon here, which would be uncool if I happened to just leave that be and let them crash to their deaths on the lunar surface. Now it may be that if I go forward a little bit, that'll fix itself, but just so you'll know what to do in case this happens to you. We're going to turn prograde. That's in the direction of your orbit, or your direction of your travel. So turn prograde. Okay, and give it a little thrust. That's enough. 5,000 meters should be enough to avoid crashing into the mountains. These are other spaceships that I have around the moon. Okay, now all this is completely unedited. If I crash, I crash. If I crash, that's what I'm going to show you. So the Kerbal's poor little lives are all depending on us. So let's do the job right for them. Okay. Periapsis looks about the same, so it's a good thing that I corrected that. Okay, let's reduce to normal time. Turn SAS off. Let's go retrograde. That's against the direction of our travel. Okay. Our objective is to close this off, so let's give it a little thrust. You'll see this is starting to bend around. Eventually it'll bend around into a loop. Again, when the velocity starts changing faster, you need to reduce your thrust accordingly. Okay, we're aiming to have that down to about 14,000 meters. Now I could have simply done a direct descent to the moon from Kerbal. That's got some problems with it, so that's not the way I do it. It is possible to do it that way. That's not the way I do it though, because it's not quite as safe. It is possible to do it that way. You could do just well, you could just simply not even go into Earth orbit. You could go a straight ascent from the launch pad to the moon, but that's not something I would recommend. Alright, that's fine for now, but as you see, my periapsis has disappeared into the surface of the moon. So when I get to the apoapsis, I'll need to do a prograde burn to bring up the periapsis to where it's at the same altitude. Generally when you first start out, you're going to want to land in a crater to start off with, one of the big craters, not one of these little dinky ones. And you're going to want to land on the light side, the side of the moon that has some light shining on it. Makes it a lot easier to land. Okay, so we're going to pick our spot right about here. And we need to give enough lead time for the orbit to decrease enough to get our destination to be in that spot. So we're going to wait a little bit. Let's check our fuel. Our fuel is fine. We got these 4 tanks, and we got a whole other tank as backup. So we're doing good. Okay. Let's do the time warp again. Alright, let's go ahead and turn SAS off. And turn retrograde. That's against the direction of our travel again. And we're going to give it full thrust. And our goal is to get this line of the orbit to go in pretty much straight up and down. That's going to make life easier for us because that means that we don't have a whole lot of horizontal velocity to get rid of. It'll be all pretty much going straight down. And that's good enough. Kill it. Okay, so you see we're going almost straight down to the surface. That's what we want to have happen because that way we don't have to worry about having to cancel out a lot of horizontal motion toward the end there. Okay, and see our retrograde indicator is pretty much right on due north here. Right here at the top of the blue part of the nav ball. Okay, now we're pretty far up now, so we just chill out for a minute until we get down to about 6,000 or 5,000 meters. 17,000 meters, 160 meters per second. So when we get down to about 6,000 meters, we're going to have to really blast it. Also, you can't always tell what altitude the ground is at. Now, imagine that the altitude of the ground here is maybe 700 meters. So you got to take that into account when you do your landing. If it's somewhere up in a high spot or a mountainous spot, that's going to be even higher. So you have to give some compensation for the fact that you may be heading for a mountain that's 4,000 meters tall. And we're going fairly fast, so let's go ahead and kill some velocity. Okay, 6,000 meters. Let's kill a lot of velocity. What can be a problem, however, is you actually kill too much velocity and start going back up again, which is not what you want. Okay, I have it set to where it's just decreasing really slowly, my speed. That's what I want. Yeah, we got a little bit of horizontal travel. Yeah, we kicked up a little bit because I wanted to try to kill off some of the and that amount of horizontal travel, probably not a big deal. Alright, looking good, looking good. Kill off a little velocity. Houston, Tranquility Base here. The Beagle has landed. We are on the moon, and we landed on quite a bit of an incline, so that was a bit of a challenge there, but we made it. We're alive. Little campers are happy. That's good. And little Shelby, Edald, and Joffbert are all happy and alive. And that concludes this tutorial. Now, when you go back to the Earth, depending on where the Earth is in the sky, right now it's not in the sky at all. If it was right up in the sky, all you have to do is just sort of point at it and go. Now, because I'm on the opposite side of the moon from the Earth, what I would have to do is go back into orbit and then just do a burn like right around here to go back in the direction of the Earth. And you don't have to do a whole lot of a burn. It doesn't take a whole lot to escape lunar gravity. And that's the end of this tutorial. Enjoy Kerbal Space Program and going to the moon.